Welcome back, and to cut straight to the punchline, what Abraham Walden said is the armor should be added to the areas without any bullet holes. So for those of you who know the answer, good for you. For those of you who this seems unintuitive to, take a minute to think about this. Why might we add parts of additional armor to the parts of the plane that aren't getting shot? Well, the reason is we have to think about where these data are coming from, and there are missing data. Only some of our planes are shot down, and the ones with which we are from which we are getting data are not these planes. These are the planes that survive. So while we don't know where the planes that get shot down are getting shot, we think the location of the bullet holes is related to the planes not returning. In other words, we can assume that the places we're seeing bullet holes are non-lethal planes. Now, again, I told you we're thinking about this like statisticians, not engineers. So there might be engineering reasons for why these parts of the plane are non-lethal. Maybe the pilot doesn't sit there. Maybe the gas tank doesn't sit there. Maybe the oxygen tank doesn't sit there. We don't know any of that right now, but what we do know is that the planes that are shot and make it back are shot there. What does this have to do with critical thinking and argument? Well, how data reach you make a difference in terms of the causal claims you can make. And this is what's known as sample selection bias. Going back to that President Trump tweet from a couple lectures ago, what does it mean when the only people responding are people who are willing to talk to a pollster at CPAC? It means you're going to have a biased sample. In other words, unobserved factors can make a simple statistical relationship difficult to interpret. Consider the claim that people who practice yoga are healthier. What are the sample selection biases here? Well, maybe healthy people already practice yoga. Or maybe the people we see practicing yoga, like out in the studios, are the ones that want to flaunt the fact that they're healthy. On your own, think about other relationships where how the data reach us is an important issue. So we have this problem. We want to know how can we overcome it. And one way we can overcome sample selection bias is with a random sample. So here, any member of the population is just as likely to be selected into the sample. And remember, a sample is just a piece of a population. So dice throwing, bingo cages, random number generators all can create random samples. But why might these samples not always be possible? Because sometimes it's prohibitively costly to randomize. Sometimes we have to deal with the samples available to us, the samples at hand. And random samples can solve this problem of selection bias, but remember, there's also a problem of sample size. We also want to reach a big enough sample to draw inference. And this is just like it's not a logic class, this is not a stats class. It's not on us to develop what appropriate sample size is here. It's on us to engage that critical part of our mind and think maybe there's something going on with the way this sample reaches us. So suppose I give you some data or draw a conclusion and I say 28% of all students. It's on us to engage that critical mind and think, well, that doesn't tell me how many students were polled. It might have just been 2 out of 7. And this is important because working with probabilities can be hard. And if we were in an in-person lecture right now, we would run through the birthday problem together. Fortunately, we can't do that. But for your own edification, I'd direct you to the reading below. And with that, let's close out this little mini lecture video. And we'll regroup in the next one to talk about some of these statistical and causal fallacies.